Hello. So in the previous video, we have seen segregate zeros and ones. We will see a little bit more complicated problem today. That is segregating zeros, ones, and twos. This is very similar to the last problem, except the problem statement is a bit complicated this time. So given randomized zeros, twos, and ones, we need to segregate them. Basically, we need to sort them, zeros to the left and twos to the right, while midsection is occupied by ones. So how do we solve this problem? So let's see. So I have an example here. We'll try to see how we can solve this problem. There are a couple of ways that you can solve this algorithm. One is using sorting technique. So sorting solves this because basically you need to segregate zeros, ones, and twos. So when you sort them, they would be automatically segregated. So that's sorting. So sorting takes n log n time. But there is a better solution than this. One thing is you can just count all the elements which are zeros, ones, and twos, and then start replacing. So this will take order of 2n time because you need to run two loops, technically which is order of n, but there is a even better solution. You can use one loop, or in single pass, you can get the task done. And using three-pointer technique, we will try to solve it. So although we're going to solve this problem using three-pointer technique can be used in solving many problems. For instance, three-sum is a problem that can be easily solved using three pointers. Okay, let's see how you're going to solve this using a single pass or three pointers. So I'm going to put my pointers here. I will call them low, and I'll call another pointer high. But where would I put the mid pointer? So interestingly, I'm going to start and the mid pointer also in the same place as that of low. So low and mid are starting from 0 while high is on n minus 1th index. Okay, so three conditions I need to check in each iteration. First thing, what is the value of mid? If value of mid is 0, I need to swap the value of mid with value of low. If mid value is 2, I need to swap it with high. If mid value is 1, I don't need to do anything except incrementing the mid pointer. Okay, let's see this. So currently the value of mid is 2. So simply I am going to swap this value 2 with high pointer. That's one thing. So the swapping happened. And then the high pointer now gets decremented. The reason it gets decremented because you are sorting the values from the right and you need to decrement the value because as your high pointer is getting decremented, all the values are segregated and those segregated values to the right are 2. Okay, so the next one is again the mid pointer is pointing to 0 now. One iteration is done. In the second iteration, the mid pointer is pointing to 0. What you need to do is now swap it with low. But honestly, low and mid are pointing to the same location. So technically no swapping happens, but your low and mid pointer both get incremented. So as you can see, to the left, zeros are getting segregated. To the right, twos are getting segregated. Eventually, you will have zeros, ones, and twos, all of them segregated. You will see once we finish this example. Okay, now again, in the next iteration, the mid is still pointing to 0. So same thing happens, low and mid get swapped, but there is no swapping needs to be done because both are pointing to the same location. Okay, in this, now we encountered a new scenario where the value of mid is 1. In such case, only the mid gets incremented. Again, that iteration is finished. The next iteration, again the value of mid is pointing to 1. So same thing happens, you need to just increment mid without doing any swapping. Okay, so now we encountered a 0 again. Here what happens, whenever you encounter 0, you need to swap it with the low pointer. So that's what I'm going to do. So I'll just basically I'm going to take this 1 and drop it and increment low and increment mid. Okay, that's another iteration. Again, check the value of mid. As you can see, every time you're worried about the value of mid, you're not really worried about the low value or high value. So eventually you will have all the values segregated. Okay, now the mid value is pointing to 2. So in that case, what happens? A swapping happens. Honestly, both the values are pointing to 2. So there is no change that you will notice, but the high value gets decremented. So high pointer is now pointing to this location. Again, we are done with one more iteration. In the next iteration, again, you will check the value of mid, which is 2. So you need to swap it with the high value. So let's go ahead and try to do that. So 2 comes here and 1 comes here and your high gets decremented. So we need to run this loop until mid and high are equal. So another iteration will be there, so which is mid is pointing to 1, so nothing really happens and mid gets incremented. So let me just move this only mid here, and mid is higher than high, and this is the end of your algorithm. As you can see, your zeros, ones and twos are segregated. So let's start writing code for this. So I'm taking 3 pointers, which is low, mid and high. High is going to start from n minus 1, while low and mid starts from 0, 0th index. Okay, so I need to run this loop until mid is less than or equals to high. The reason I need to run till mid less than or equals to high is because I want to make sure that everything is sorted. Otherwise, I probably will end up having one item unsorted if I just run till mid is less than high. So just to be sure that everything is sorted and we are not missing out any edge cases, so I'll run this loop till less than or equals to high. And as I said, 3 conditions we need to check. If the value of mid is 1, I don't need to do anything, simply increment the mid pointer value, that's all. Because in the middle we want all the ones to be segregated, so if a of mid contains 1, just increment it. Otherwise, I'm going to run just check whether a of mid is 0. If that's the case, I need to swap. I'll implement the swap function later, but I need to swap mid and low and then increment low and increment mid. Otherwise, the another condition is, what if the a of mid value is 2? In that case, I need to swap a of mid with high. I need to decrement high, and that's our algorithm. And once when the loop finishes, you will end up having a segregated array or sorted array. So let's go ahead and give it a try. I'm going to submit. Okay, the swap function I forgot to implement. Let's go ahead and try to implement next. So I'm going to simply write a static method. This returns nothing. It takes array and 2 indexes, say I and j. I need a temporary variable. I'll swap a of I with a of j, and a of j would be assigned 10. And that's all. Let's give it a try one more time. All good. I'll see you in the next one.